Hey everyone, in this video we're going to go through some gas law calculations, specifically with Charles and Gay-Lussac's laws. So the first thing that you need to keep in mind anytime we're doing a gas law calculation is that the temperature must always be in Kelvin. So we cannot plug in numbers into the formulas unless the temperatures are in Kelvin. So I'm just going to write that off to the side here. Temperatures must be in Kelvin. All the other units don't matter as long as they match like before and after, but temperature for sure has to be in Kelvin or the problem won't work. So that's what I'm going to look for when I first read a question. 600 milliliter sample of nitrogen is warmed from 77 degrees Celsius. I'm going to cross that out, and instead I'm going to put 350. And remember to go from Celsius to Kelvin, we add 273. So I just did 77 plus 273. And then 86 degrees Celsius is going to be 359 Kelvin there. Once I've done that first step, which is, make sure my temperatures are in Kelvin, then I can go ahead and write out my variables. And so because I see a volume here, milliliters is volume, and temperature, I know that that's going to be Charles' law. So I'm going to have a V1, a T1, and a V2, and a T2, where my ones represent my before and my twos represent my after. And so you want to look for kind of keywords. So it says it warmed from this to this. Well, that right there, that's pretty easy to identify my before and after. So my before is 350 Kelvin for temperature, and then 359, 359 Kelvin. Sorry, I'm going to brain fart. And then we need to look for volume. So the only other number that's given here is the 600 milliliter sample. And it's warmed from this to this, so that must be my starting volume. So I'm going to have 600 milliliters. And then find its new volume, and so that's going to be my X. And of course, pressure remains constant. Pressure has to remain constant when we're doing Charles' law. From here, we can plug in our numbers. So I have 600 divided by 350 equals X over 359. And there's a couple different ways to do this. If you're strong with algebra, then you can just do, how it looks. You 600 divided by 350 and then multiply 359 to get to the other side. If that's too much for you and that's too confusing, then I recommend that everyone just cross multiply. So when we cross multiply, we set the two sides equal to each other. So it would be 600 times 359 equals 350 X. And so now that's a lot easier algebraically to solve for. We just divide, multiply those two and then divide by 350 on both sides. So how you get to the answer is up to you, but once you get to the answer, it should be for this problem 615.43. Now the other thing is what are the units? And so if we go back here, we know it's a volume. So our units should be something related to volume. Specifically, we want our ending units to match what we started with. And since I started with milliliters, then my final answer is going to be in milliliters. So the two most important things from this problem that we need to take away is that the temperature must be in Kelvin. So of course you have to go through and convert any Kelvin temperatures. And then the other thing is your ending unit. So you want to make sure that whatever you start with is the same as what you end with. The last thing that I wanted to point out to you guys is when a question refers to STP. So let me see if I can find an example here. And of course, I'm not going to. Nope, I'm not seeing one. So let's go to the notes from today. So here it says a rigid container at STP is taken to Mount Everest and the pressure inside the container drastically falls, blah, blah, blah. A lot of students are going to see this. They're going to see one number and they're going to freak out because as we know, we need 4 different, variables to be filled in. So if this is pressure and it wants to know temperature. So I'm going to have P1, T1, P2, and T2. Well, using context clues, I can figure out that this is going to be my P2 because it says the container, the pressure falls to, meaning it becomes this. So my P2 is 86.1 kPa. And my T2, well, that's the question here. What is the temperature? And so that's my X. And now everyone's like, well, I don't have any other numbers, so I don't know what to do. Well, you have to really read the question. And here it says a rigid container at STP. So sure, it doesn't give you numbers, but it tells you what the numbers are. And we know the STP values, right, because we memorize them. And so for STP, our standard temperatures are going to be 0 degrees Celsius or 273 Kelvin. And I asked you which one should we use, and hopefully you answered this one. Why? Because of, well, it's not on this page anymore, but all calculations must be in Kelvin, right? Forget where is that? Here. Look at that. Temperature must be in Kelvin. Kelvin temperatures. Okay, so that's why we're doing that. And then that gives me my T1 to 73. And we have a lot of pressure values at STP. So the question is, well, which one do I pick? And again, this goes back to the units. We want our units to match. And so if I'm given a kPa, then I want to use a kPa. And 101.3 is our standard pressure in units kPa. And so that's what we plug in there, 101.3 kPa. And from that, you just plug it in and solve for the final answer. And these notes are going to be in your guys' notebook. So you can go ahead and check out the answer if you haven't done this question already in the content library. So hopefully that helps clear some things up. Remember, the three main points that you need to take away from this are that temperature must be in Kelvin. Your beginning units should always match, your ending units. And then anytime it tells or it mentions or talks about STP, you're probably going to have to come up with the values on your own. Even though it doesn't give them to you, it tells you what they should be. So you have to commit those to memory. And that's it. Thanks. Good luck.